Hello guys, hope you all are doing well. So it's been so long. Actually, the main reason was much of the people are not seeing the videos, so views are very less. So it was just a kind of demotivation, and but that's fine. And the second point is that now the companies are not recruiting through Gate. So I felt that uh, much people will not be interested in Gate. So okay, but complete slowly. But I don't know whether I will complete all the question paper till the next year paper. So sorry for that. So we have already discussed the section A of 2010. Now this is the section B of 2010. Then we will start solving the questions of I think till 2000 we have done 2001, 2002 we will see. Okay. So very first question we have, it is straightforward maths question. I, I don't think so. There is a need for the discussion, but we'll discuss in a quick way. So, very first, this is the equation, and these are the boundary conditions. Okay, this is the equation. Sorry. So so, so this is the equation. This is the equation. This is the boundary condition. So, very first, we have the equation converting into in m form. Okay, we all know that basic maths, engineering mathematics. Now, quadratic formula. Okay, so we are getting this, and we know that for this type of solution, we have the solution y is equal to e to power alpha t a sin bt plus b cos bt. That is a straightforward solution. So, पहली boundary condition लेते हैं, y is equal to t equal to 0 equal to 0. So, putting value of y and t, we will get b equal to 0, and putting that b is equal to 0 in the this equation. Okay. So, we will get y is equal to e to power minus t a cos t. Okay, get this. After putting b equal to 0 in this, okay, I will get this. Now, since b is 0, we will get this. Now, differentiating one more time. Why differentiating? Because the boundary condition is saying that. Differentiate it and we will get this. Now, second boundary condition, putting the values, we will get this. It is. Okay, so this is our answer. Okay, so next question. This is straightforward. Find the curl u cross v. So we have u, we have v. Okay, velocity vectors in the x direction and y direction. So straightforward, u cross v is this, and curl of u cross v, again we have to do our u cross v is this. Okay, curl of u cross v, we know that how to find curl. This is curl. Okay, straightforward. Now, x and y are independent random variables. X follows binomial distribution with n equal to 5 and p is equal to probability of x is 1 by 2. Y takes the integer value 1 and 2. Okay, so y belongs to only 1 and 2 with equal probability. With equal probability. Then the probability that x equal to y. Okay, so very first, x follows the binomial distribution with n is equal to 5 and p is equal to 1 by 2. Y belongs to 1 and 2 with equal probability. That is, probability of y equal to 1 equal to probability of y equal to 2 equal to 1 by 2. None other option is possible. Okay, so x and y are independent. So we can write this. Okay, for independent uh, conditions, this is the, we can write the above conditions like this. X and y are independent. So probability of x equal to y is equal to probability of x equal to 1 into probability of y equal to 1 plus probability of x equal to 2 probability of y equal to 2. Hope you understand this. Okay, now binomial distribution, you know that this is the formula for binomial distribution. So for x equal to 1, for x equal to 2, and putting the value in this equation we have discussed, because the probability of y is equal to the probability of x. Okay, so we will getting 15 by 64 straightforward. This is very simple question. You can do it yourself. Okay, so I will not discuss it now. For a function gx, if g0 equal to 0 and g test 0 equal to 2, then it means g when x equal to 0, g equal to 0, when x equal to 0, g dash differentiation of g is 2. Okay, so you'll see. So limit, this is the given equation. Okay, so for dt, for dt 2 by x will be constant, we will take it out. Now t dt, okay, limit x equal to 0, 2 by x is same as it is. Okay, now t square by 2 integrating t dt, limit. Now the limit was 0 to gx. Okay, so t square will be gx square upon gx square. Okay, and 2 and 2 will cancel out. Now taking x inside, limit x equal to 0. Okay, now if I will put 0 here and 0 here, so this will become 0 by 0 form. So applying L'Hospital rule, so 2 gx and 1 differentiation of gx is g dash x upon x is 1 and differentiation of x is 1. So again putting all the values we will get 0. So answer is 0. Okay, very simple. At constant T and P, the molar density of a binary mixture is given by rho equal to 1 plus x2, where x2 is the mole fraction of component 2. x2 is the mole fraction of component 2. Okay. Oh, okay. The partial molar volume at infinite dilution for component 1, V1 bar infinite. Okay. So this is if you know what is the formula for infinite dilution and for partial molar volume, this is very uh, easy question. And the trick here is you know the dimensional analysis very well. The dimension, equating the dimension. So very first we have the molar densities. That means mole per meter cube. If I want to find molar volume, so volume is meter cube, but molar volume per mole. So just reciprocal it. Okay, so molar volume is 1 upon 1 plus x2. Fine. Okay. Partial molar volume formula. So this is the partial molar volume formula. Where it is written, you can refer any book. Uh, y YBC Rao, Gopinath. No, what is that? Um, KB Narayana. And Gopinath Haldar is there. That is a very good book. But the problem with this book is it has many errors. You have to be very careful while solving the questions. Okay, but Gopinath Haldar has a wide variety of numerical problems. Okay, so you can refer these. Okay, so v1 equal to v minus x. Now what we have done, see, this is dx1 and this is dx2. How? X1 plus x2 is equal to 1, dx1 plus dx equal to 0, differentiated, and dx1 is equal to minus dx2. So when I will replace dx1 with minus dx2, so a minus sign will come here. Okay, now putting the values. Okay, at v1 bar will be v1 bar infinity when x1 will 0. That means we are diluting the one component at infinite times. Diluting the one component in infinite time that tend to be 0. वो 0 हो जाएगा. इतना dilute कर दिया है उसको कि खत्म ही कर दिया है. तो x2 1 हो जाएगा. Okay. So v1 bar infinity is equal to 0.75. Straightforward. Okay, so this is like average question. A saturated solution at 30 degrees Celsius contains 5 mole of solute per kg of solvent. 5 mole of solute per kg of solvent. Molecular weight 20 kg. Okay, solvent का molecular weight और solute होगा. Solubility at 100 degrees Celsius 10 mole of the solute per kg of solvent. If 10 kg of original solution is heated at 100, then the weight, the additional solute that can be dissolved. Okay, molecular weight of solute is 50 kg per kilomole. So 0.05 50 kg per kilomole. So if I will convert it into kg per mole, then 0.05 kg per mole. We have 10 kg of saturated solution. That means saturated solution at 30 degrees Celsius, 10 kg. At 30 degrees Celsius, that is the original solution. We are heating this at 100 degrees Celsius. Okay. So at 30 degrees Celsius, solubility is 5 moles of solute per kg of solvent. At 100 degree, 10 moles of solute per kg of solvent. Now, mass of solute and solvent in original solution, that is 10 kg in original solution. Let mass of the solvent is x kg. Solubility at 30 degrees Celsius, 5 moles per kg solvent into kg solvent. So 5x. Mass of solute 5x into 0.05 kg, that is 0.25 x kg. Straightforward, equating the dimensions. Now total solution at the original condition, x plus 0.25 x is equal to 1.25 equal to 10. So x will come 8 kg. That is x the solution quantity of the solvent. That means 2 kg will be the solute, 10 minus 8 will be the solute. Okay. Now maximum mole that can be dissolved, 10 into it 80 moles. Mass of solute that can be dissolved, 80 into 0.05 mole equal to 4 kg. So additional solute will be 2 kg. Okay, straightforward. Okay. The product of combustion of methane in atmospheric air, 21% something, have the following composition: CO2, CO2, CO, N2. Product, that means CO2 is not completely converted. The ratio of moles of CH4 to moles of O2 in the feed stream. Okay, we know that volume percentage equal to pressure percentage is equal to mole percentage. Where it is written? Chemical process calculation, M Himmelblau. Okay, you can refer M Himmelblau. Or so in the first 2 or 3 chapter you will find this equation, that volume percentage equal to pressure percentage equal to mole percentage. Okay. Now let 100 kilomole of product gas, the gas at product end of the reaction. CO2 is 10 kg. Okay, why we are taking 100? So that we will get exactly the same number as the mole percent. So 10 kilomole, CO2 is 0.53 kilomole. So CH4 totally reacted by both the reaction. This is the equation. Okay. N2 is 87.10. It is a tie component. Okay, so it remains exactly the same quantity present in the reactant. Okay, so air fed, this straightforward. Okay, O2 fed, so air fed is itna, and O2 percentage in air is 0.21. So O2 fed this. Okay, moles of CH4 for O2 fed, so 0.45. Okay, so straightforward. But I'll request you guys, if you are going forget, then uh, it doesn't matter how simple the question of process calculation is. It seems, sometimes it seems it is very simple, but approach the question at the end of all the questions you have done. Like process calculation, preference should be given at the last. That I'll do all the question of process calculation at the last. It will save time. Otherwise, the questions of process calculation seems to be very easy, but when you will go into the question, your 10 to 15 minutes will be gone. That is totally uh, true. Okay, so be careful. It is totally up to you. I'm just giving a suggestion. Okay, ah, so this is the question. The diameter of a drop of a liquid fuel changes with time due to the combustion. According to the relationship D is equal to D naught 1 minus T upon TB. While burning, the drop was at its terminal velocity and Stokes flow regime. Okay, the distance it will travel before complete combustion given by. Okay, so solution we know that the terminal velocity and the Stokes regime is given by this. So this is the terminal velocity. Okay, the whole term. Since the diameter is changing with time, so velocity is equal to distance equal to speed into time. Dust distance equal to speed into time. Okay, so when I want speed, so distance upon time should be there. So this is the distance and this is the time. So dy dx and it is changing. So equation. Now writing dp in form of d naught because this is a relationship with respect to t. Okay, so and rearranging it ultimately we'll find this. So x is equal to rho g d naught square del rho upon 18 mu f. Okay, and this integration 0 dv 1 minus t upon tv square. Now when you will solve this you will get answer c. Okay, putting the limits. Okay, 36. It is very simple question, just read those things and keep in mind. Okay, uh, every year gate is asking these type of questions. Okay, so read it, and if you have any confusion just comment it below. I will clarify it as soon as possible. Okay, I'm not going to read. So this is sorry, this is not the answer. Profile 1 r, profile 1 profile 1 and profile 2 p, profile 1 r, profile 2 p. So this is, and 3 is q, 3 is q. So this is the answer. This is not the answer. This is again straightforward question. So this is our answer very first. So we have to find this f11, f12, f21, f2. Okay, view factor matrix. We called it view factor matrix. Okay, this is the uh, diagram. So very first, if I will see it from here, so this is the diagram. In this, the heat is going here. Okay, let's see. Very first, f11 equal to 0. Why? Because there is no heat from 1 to 1. This is also 1 and this is also 1. So no heat from 1 to 1. No internal heat. And from outside it is not possible to go heat from 1 to 1. No chance. It will always go 1 to 2. Okay. So 1 1 is 0. So 1 2 is 1. Yani ki that means 1 2 is 1. That means all the heat from the inner cylinder is going to the outer cylinder. 1 to 1 means 100%. ठीक है? Okay. Now we know that A1 F1 to A2 F21. We called it I think reciprocatory equation or something like that. I forgot. I don't know. Reciprocating. What is that? Reciprocating or something. I don't know. Just check it. I just write the equation because it was in my mind. So now putting the values, F12 is 1, A1 is area of 1, figure 1, and the area of figure 2 and F21. So we will get F21 is 0.5. Now F21 plus F22, why? F21, it is possible for second to go at 2 because 2 to 2, because no outside of heat, only inside heat. So F22 is possible and F21 is also possible. So F22 plus F21 is 1 because like not half, some of the heat going at 1 from some of the heat is going to 2 from 2 and some of the heat is going to 1 at from 2. Okay, so F1 2 1 2 plus F2 is 1. So F22 is 1. That means now it is confirmed that 50% is going to 1 and 50% is going to 2 from the 2 only. Okay. So now we'll put F11, F2. So F11 is 0, 0, 0, 1.5.5, 0, 1.5.5. Okay. So this is straightforward question. Mass flux is equal to mass transfer coefficient to driving force. So N is equal to Ky P set minus PA, refer to mass transfer coefficient. And I have shared my notes in my earlier videos when we were solving 1990s or 91. Okay, so go through that. Mass transfer coefficient is very, very good explained there. Now, what we have done, so N is equal to flux, mass transfer coefficient, and driving force. Okay. So N is equal to, we have taken P set outside, and okay, now. So this, when we are taking P set, PA upon P set will become relative humidity. So this is the equation. For condition 1, everything is given. For condition 2, everything is given. Divide 2, 3, we will get this. Okay, so this question is important, but I forgot the solution of this question, and the solution even misplaced from me. I don't know where it is. I tried many times to solve this question, but I'm unable to solve, and a little bit lengthy. This question is a little bit lengthy, but this is one of the most important question. So maybe later, but I'm not sure that I'll solve it. Maybe later we'll discuss this. Okay. Okay. This is a theoretical question. So I'm sharing this. Just read it. Okay. And this is from H. Scott Fogler, one of the most important and interesting book of chemical reaction engineering. Very, very interesting book. If you want to study, just go through this. So this is chapter 16. Okay. So see, the solution is here. We need this. So just compare it. Tau p is the PFR time and tau s is CSTR time. Okay. So just read this. This is complete. Okay. Autocatalytic reaction, no need to explain, no need to discuss. This is the temperature profile. Okay. Okay. A block diagram for a control system is shown below. The steady state gain of the closed loop system between YES and segment. Steady state gain, that means at S equal to 0. So very first, this is the equation. Understand, we will understand this equation. Very first, this is point 2. Okay. This is point 2 coming from YS. So point 2 YS is here. Where this? Point 2 YS. And going here and meeting with RS point 2. RS point 2. Okay. So point 2 RS, which is going here, minus, this is minus point 2 YS. Point 2 YS. Into, now no signal is coming, but directly multiplication of this whole term. So multiplying this whole term. Again, no signal is coming from here or somewhere. So direct multiplying this. So direct multiplying this, and which is equal to YS. Whole is going at the out. And we will not consider this because we have already taken into consideration at this point. Okay. Now, solve this again. Rearranging and solving this. I solved this and getting this step. Okay. So taking RS and YS at the other side, like taking complete RS at one side and YS in the other side. So you'll get at steady state Y is equal to 0. Put Y is equal to 0. 4/9. Okay. This is also, consider the cascade control configuration shown in the figure. The system is stable when KC2 is. So we have to apply Raoult theorem for KC2. So very first we have to solve the inner loop. We have to solve this inner loop. So for inner loop, we know that for inner loop, Ys upon U1s. This is for inner loop. And if there is minus, then there will be plus, and there is plus, there will be minus. Okay, so Kc2 into S, Kc2 into this upon 1 plus Kc2 into this into, if something is there, then like uh, 1 2 3 going here. Okay, everything. So uh, like this is y and this is u. So y upon u is equal to 1 into 2 upon 1 plus, this is minus, going here, this is minus 1, there is minus, so there will be plus, if there will be plus, there will be minus. Okay, so 1 plus 1 into 2 into 3, so this is the thing. But here we have everything, like don't, like we do not have anything, so we consider it as 1, so into 1. Okay, so remain the same. So this is the inner loop solved and will be aligned with zero point 0.5, that is this, and this whole, this, now ys. Okay, now final ys, again we don't have it, and this rs now. Okay, eraser. So solving this, equating this, aligning with the main part. Now taking kc2, like we have everywhere kc2 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 for stable system, 1 plus this, and we will get ultimately this equation. And for kc2 apply Routh array. Routh array, I hope you know how to apply Routh array. If you don't know, see my earlier videos. Okay, it is there. I'm not gonna solve it here. Okay, consider the process shown in the figure below. A constant head pump transfer a liquid from tank maintain at 20 psi. So tank is 20 psi to a reactor operating 100 psi. Okay, 100 psi through a heat exchanger and a control valve. Heat exchanger, control valve, and the pump is there. The tank. Okay. At the design condition, liquid flow rate is 1000 liter per minute, while the pressure drop across the heat exchanger is 40 psi. Heat exchanger is 40 psi. Okay, and the across the controller is 20 psi. Controller 20 psi. Assume that the pressure drop across the heat exchanger varies as the square of the flow rate. Okay, if the flow rate is reduced to 500 liter per minute, then the pressure drop across the. So very first we have this diagram. So let us understand. This is, I am marking it PA, and this is PB. That is pressure A and pressure B. So if I say pressure along the heat exchanger, so PA minus PB, that is, so pressure PA minus PB 40, because it is written here. See, 40, and PB minus P2, if this is P2 and this is P1, same P1 will be there here. So PB minus P2 is 20. Now PB minus 100 is equal to 20, because P2 is 100. So PB is equal to 120. PB is equal to 120. PA is equal to 160. Because once we will get PA, we get PA, putting PB, putting in P, we will get PA. Now, case 1, liquid flow rate is 1000 liter per minute. Case 2, liquid flow rate is 500 liter per minute. Let pressure drop across heat exchanger, not let, because it is happening. Del P is equal to KQ square. Case 1. Case 2, dividing. Okay. So, pressure drop at will be 10, that is PA minus PB across the heat exchanger, because the heat exchanger varies at the square of the flow rate. So P2 is equal to 150. and new pressure drop across the controller 150 minus 50 psi, straightforward. This is also formula based question. So this is capitalized cost for first condition, for second condition, putting all the values for first condition, because we don't have sorry sorry, this will be P minus salvage value. Similarly here, P minus salvage value. So this is okay, putting all the values, find P. So you will get, I think, 6.9 lakhs or something, or 6.5. Okay. So this is, so till here we have solved section B of 2010. Now we have only remaining with the four questions. That is very good questions. One is this, second, third, and fourth. So we'll solve these all these questions in the next part. Okay. So bye guys. Take care. Study hard.